Hello, I hope that you are doing well. This is Kazanadavi from a Sager Educational Group. In this video, I'm going to tell you how you can simulate a piezoelectric system, a piezoelectric in a liquid materials. So you would investigate the effect of the uh, tension on the electrical currents and vice versa. So in this regard, so we done the simulation. So it's a kind of cube that contains fluid like a water, and it's like a piezoelectric materials that is defined in this shape, and for this purpose we defined we use the different features in COMSOL Multiphysics for drawing the geometry, so of cone with these dimensions derived, and then we applied this part for taking a kind of intersection of the cone. Second cone was also defined accordingly for creating the second layer on the top of the first layer, and the third layer is like another cone with a block to have the intersection for the third layer. Accordingly, we have the fourth one, and then we just differentiate this shape from the first geometry that we have, and finally we get to have this shape. A block was defined firstly for the first electrode. So we need to define all electrodes in different sides of the piezoelectric material. And finally, we have a kind of cube around the piezoelectric that moves in the water. The materials is silicon for the piezoelectric materials. It's zinc oxide for electrodes, and it's silicon for this layer, second layer, and water liquid for this dummy. So we define the physics of solid mechanic and electrostatic. So for the case of materials properties, we defined like CNT or carbon nanotubes for just modification of this layer, the down layer. So it's the properties that we defined for this material. The boundary condition of free applied for these boundary conditions. But the thing is that we need to just first define the fixed constraints. So two sides of the piezoelectric materials are fixed. And for the case of piezoelectric materials, we define the like materials properties from the material sections that we are defined already. And exactly the same for this section. For the electrostatic part, we have a zero charge part here, and we have like a ground boundary condition under the connection between these parts, piezoelectrics with this shape, and electrical potential on the upper side. It's 10 volt. So we cope that things together, since when you are using piezoelectric materials that commonly is using for investigation of effect of electrical field on on physical tension of materials, piezoelectric materials, that they have like applications for sounds detection, and sometimes producing sounds using electrical fields. So we did the meshing system, using et al. Meshing approach. And for the first step, we did the simulation as a stationary, and then in the second stage, we did it like engine frequency with different frequency uh, of like electrostatic fields. And here is the results that we reached to. So we can see that with different hertz, how geometry is changing. And also it is the electrical potential and the stress. Thank you so much.